Hello all, this is Ravina Judy Dolly from the Department of ECE, Karunya University. I would like to handle a topic on semiconductors. Semiconductors are nothing but they partially conduct, and their valence electrons are 4 in number. Now, the widely used semiconductors we can say it to be silicon, germanium, etc. Now, these semiconductors are categorized into two types. One you call it to be an intrinsic semiconductor, and the next one to be an extrinsic semiconductor. And why these two types of semiconductors? Intrinsic semiconductors are nothing but they exist in their pure form. If you take silicon, silicon means silicon as such. Germanium means germanium as such. Now, when the researchers they tried to improve the current conduction capability. So, to increase the current conduction capability, they went in for an extrinsic semiconductor. This extrinsic semiconductors are nothing but we are going to add some impurities to a pure semiconductor. So, impurities are added to a pure semiconductor. And again, based on these type of impurities, they are categorized into two types. The extrinsic semiconductors are categorized into two types based on the impurities added. So, one we add a trivalent impurity. What is meant by trivalent impurity? They have 3 valence electrons. And the other case is a pentavalent impurity. What is meant by a pentavalent impurity? The valence electrons are 5 in number. So, if we are adding trivalent impurity to a pure semiconductor, it means a p-type semiconductor. And if we are adding pentavalent impurity to a pure semiconductor, it means an n-type semiconductor. So, now we'll learn in detail about the p-type and n-type semiconductors. So, first to deal with n-type semiconductor. N-type semiconductors are nothing but we are going to add a pentavalent impurity to a pure semiconductor. Okay, just to improve the current conduction capability. Now we'll see what happens. So now we are going to take some pentavalent impurities. Namely, I can say some arsenic, antimony or phosphorus. Okay, these are all having pentavalent, they are all called pentavalent atoms. Okay, now if I take a phosphorus atom, okay, now to this pentavalent impurity we are going to add a pure semiconductor. So we have pure semiconductors, namely silicon, to form covalent bonds. Now, this silicon has how many valence electrons? They have 4 valence electrons along with them. Similarly, all the silicon atoms have 4 valence electrons. And now, how many does the phosphorus atom has? It has 5 valence electrons. So, now 1, 2, 3, 4 and one more 5. Now, to this we are covalent bonding. What is covalent bonding? They are nothing but mutual sharing of electrons. So, this silicon atom shares one electron with the silicon atom. So, it is covalent bonded. So, all these have formed bonds with each other because there is a mutual sharing happening in between them. And now, this phosphorus atom also gives an electron for bonding. Here you can bond it, here also we can bond, and here also it can be bonded. And now you can see there is one electron being left out. One electron, this is being left out. And this electron is responsible for current conduction. Now this electron becomes a free electron now which is responsible for current conduction. Similarly, the lattice structure goes on. So, we will get more free electrons for current conduction capability. So to increase the current conduction capability, they went in for n-type semiconductors. So when we say there are more number of free electrons, the majority charge carriers would be electrons. And the minority charge carriers would be holes. And now, since this n-type semiconductor is donating an electron, we call these type of n-type semiconductors to be donors. Why do we call them donors? Because they donate one electron for current conduction. So they are called as donors. So this is about your n-type semiconductors. So we will have more number of free electrons for current conduction. Now moving on to the p-type semiconductor. So p-type semiconductor, we are adding trivalent impurities to a pure semiconductor. And some trivalent impurities may be gallium, indium, etc. What is meant by trivalent? We have 3 valence electrons. So now to this gallium, I am taking gallium atom, okay, which has how many valence electrons? 3 valence electrons. To this gallium, we add a pure semiconductor, which is silicon. Now again, silicon atom has 4 valence electrons to it. So all these 4 electrons form covalent bond with each other. So now I am going to form covalent bonds with each other. And now this gallium shares one electron. So there is a bond being formed. Here another gallium atom, one electron is being formed paired with this silicon atom. And again one more electron is being bonded. And now here we have one electron, but we don't have an electron from gallium to donate. So here we have a hole to be developed. And here we have an electron. So now this hole is nothing but, we call it to be a missing electron. A missing electron is nothing but a hole. So we'll have a crystal lattice structure going on. So we'll have so many holes for current conduction. So these holes are responsible for current conduction. So in a p-type semiconductor, the majority charge carriers would be holes, and the minority charge carriers would be electrons. And this hole is now ready to accept an electron to fill the hole. So if an electron comes and occupies its place, again it forms a covalent bond with it. So now this hole, you call it to be, this atom, this p-type semiconductor, we call it to be acceptors. Why? Because they are ready to accept an electron to form a covalent bond. And this is about your p-type semiconductor. So actually semiconductors, they partially conduct and they have 4 valence electrons. And now this semiconductors are categorized into 2 types. They are called as intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor is nothing but semiconductor in its pure form. Extrinsic semiconductor is nothing but addition of impurities to a pure semiconductor. What is that addition of impurities to a pure semiconductor mean? It is nothing but doping. The process of doping is nothing but addition of impurities to a pure semiconductor. The impurities may be trivalent or pentavalent. If it is a pentavalent impurity, we call it to be an n-type semiconductor. If it is a trivalent impurity, we call it to be a p-type semiconductor. And now covalent bonds are being formed. So we call n-type semiconductors to be donors and p-type semiconductors to be acceptors. So thank you.